Have you ever been sitting at the breakfast table, looked at your spoon, and just thought, why does my reflection look so incredibly weird? Well, today we're going to solve that little mystery. We're diving into the science behind those strange, distorted images we see every day, and it all starts right there in your kitchen drawer.
No, seriously. If you have a spoon nearby, go grab it. Take a look. On one side, you're all stretched out, maybe even completely upside down, kind of like in a funhouse mirror. But then you flip it over and bam, suddenly you're all squished, but you're the right way up. What is going on here?
So let's break it down. You've got the inner scooped out surface, which gives you that bigger, often upside down image. Then there's the outer bulging surface, and that one gives you a smaller but always upright reflection. It's one object, but it's showing you two totally different realities, and that is the mystery we're cracking today. And believe it or not, if this simple kitchen utensil is actually our key, it's about to unlock some of the most fundamental ideas about how light works and how we see the world. Okay, but before we can get to the spoon's secrets, we need to back up a little bit. We need to understand the very basic science of sight itself. Because you see, to figure out mirrors, we first have to get a handle on how we're able to see anything at all. And it all starts with this one super simple fact. If you're in total darkness, you see, well, nothing. Absolutely nothing. Light is the one essential non-negotiable ingredient for vision. So you might be thinking, how do we see things that don't make their own light, like a book or a table? Well, the answer is a little thing called reflection. It's just the process of light bouncing off of a surface.
Think of it as a three-step journey. First, light from a source, say the sun or a lamp, shoots out and hits an object. Second, that light bounces right off of it. And third, those bouncing rays of light travel into our eyes, and our brain puts together the image. It's literally the reason you can see the world around you. Now, here's where it gets really cool. This bouncing action, it isn't random. It's not just chaos. Light is incredibly predictable. In fact, it follows two very simple, unbreakable laws every single time it bounces off a surface.
First thing you gotta know is that light always, and I mean always, travels in a perfectly straight line. We call this a ray of light. It's the whole reason you can't see around corners and why shadows are so sharp and defined.
Okay, so law number one is just beautiful in its simplicity. The angle that light hits a surface is the exact same as the angle that it bounces off. Think of it like a perfect bank shot in a game of pool. And law number two, that just means the incoming ray of light and the bouncing ray of light stay flat. It doesn't suddenly veer off into another dimension. And when you take these two simple laws and apply them to a flat, shiny surface, like your bathroom mirror, they work together perfectly to create that one-to-one reflection we're all so used to. The image is the same size, it's not distorted, it just works.
All right, we've got our clues. We know we need light to see, we know it travels in straight lines, and we know it reflects according to two very strict rules. Now, let's take all that knowledge and head back to our original crime scene, the spoon. We know what happens on a nice, flat surface, but what happens when those predictable, orderly laws of reflection meet a surface that isn't flat? What happens when you throw a curveball at them?
And this right here is where it all clicks into place. That inner surface of the spoon, the one that makes you look bigger or upside down, that's what science calls a concave mirror. And the outer surface, the one that makes you look smaller but always upright, that's a convex mirror. A concave mirror is basically any reflecting surface that curves inward, away from you, just like the bowl of a spoon. And because of that inward curve, it bends light rays toward a single point. This can either make an image look way bigger up close, or if you're far enough away, it flips it completely upside down. And on the flip side, you've got a convex mirror. This one bulges outward, towards you. This curve does the opposite. It causes the reflected rays of light to spread out. And because those rays are spreading apart, the image they create always looks smaller, but it stays right side up. So, we've cracked the case of the spoon. But what's truly amazing is that this isn't just some fun fact about your kitchen stuff. These exact same principles are at work in some of the most powerful and important tools we use all around us every single day. You see, your spoon is really just two types of what scientists call a spherical mirror, which is basically just a mirror that's shaped like a slice of a sphere. One side caves in, the other side bulges out. One side is concave, the other is convex. And this is the whoa moment.
That convex mirror on the back of the spoon, the one that makes a smaller image, that effect gives you a super wide view, which is exactly why we use them for the side mirrors on our cars and for those big security mirrors in stores. And the concave mirror, the inside of the spoon, its ability to focus light and magnify things is the secret behind giant reflecting telescopes that let us see distant galaxies and maybe even the makeup mirror you used this morning.
So that weird reflection in your spoon, it's a direct line to the physics that lets us explore the cosmos and stay safe on the highway. The principles are exactly the same. So from now on, when you see your reflection in a shiny, curved surface, you'll know the secret. Ask yourself, what kind of mirror am I looking at, and what is it showing me?